Hello everyone, I'm Melis Layda, a PhD student at the Max Planck Institute for Intelligent Systems. In this video, I'll briefly talk about our work titled Adversarial Training for Defense Against Label Poisoning Attacks, which is a joint work with Volkan Cevher and Michael Mühlebach. Data poisoning is a critical security concern in machine learning, where attackers intentionally manipulate training data, either in the form of future perturbations or label poisoning, to make the models learn incorrect input-output associations. The consequences of data poisoning can be severe, especially in critical applications such as medical diagnosis, fraud detection, autonomous driving. In this work, we focus on label poisoning attacks, where the attacker's goal is to strategically mislabeling data to maximize classification error. For instance, let's consider a real-world task, IMDb sentiment analysis, where the attackers can flip labels of toxic movie reviews from negative to positive to mislead models and erode user trust. Machine learning models are vulnerable to such label manipulations, and here we provide a clear example of this. We fine-tuned a foundation model, Roberta, for this task under varying label poisoning levels. As we can see on the right, when the data set gets more adversarial, the test accuracy of the model significantly decreases. And this shows us even the representations learned by such foundation models are not robust enough against label poisoning attacks. So having highlighted these vulnerabilities, now let's explore how we address label poisoning using our proposed defense called FLORAL. FLORAL is a novel adversarial training defense based on support vector machines. The key idea of FLORAL is to make the model learn from adversarially labeled examples. We formulate our adversarial training routine as a game between a nonlinear SVM and an attacker. Here, in this interplay, the model first shares its dual parameters with the attacker. The attacker uses these to identify the top K most influential data points that affect the model's decision boundary and poisons their labels. Then the model learns from the dataset with adversarial labels. This iterative interplay helps the model to learn from adversarial configurations of the decision boundary. Specifically, we formulate this game using a bilevel optimization formulation. The outer problem corresponds to model's problem, and the inner problem is the attacker's problem. In the outer problem, we train a kernel SVM under poisoned labels, and the inner problem generates adversarial labels by identifying the top K support vectors. The key idea here is that support vectors reflect the most influential training points, and overall formulation forms an adversarial training routine. We assess FLORAL's performance under IMDb sentiment analysis task, which we have shown Roberta's vulnerability to label poisoning attacks. As you see on the right, FLORAL effectively mitigates the impact of label poisoning and achieving significantly high robust accuracy compared to Roberta. We further use a synthetic benchmark Moon dataset, which is illustrated here on the right. And our experiments also confirm that FLORAL is effective in achieving higher robust test accuracy compared to various robust baselines. Particularly when the dataset is severely poisoned, FLORAL significantly outperforms all baselines. In our paper, we provide further insights and analysis, including decision boundary analysis, stability and convergence of our algorithm, and performance evaluation under other label poisoning attacks from the literature. You can find more details in our paper and also check our open source code. Thanks a lot for your attention.